Our learning target today is I can generate equivalent expressions by combining like terms. In class lately, we've been talking about terms and coefficients and constants and all this stuff. Well, today we're going to look at what like terms are. So in algebraic expressions, like terms have two important things in common. These two important things are like terms must have the same variable raised to the same power. And remember, when we talk about power, this is whenever we're talking about exponents such as squared, cubed, or to the fifth power, to the 10th power, whatever it may be. Number 2 says a variable with no coefficient has a constant of 1. So if you look down here at our example we're going to work with in a minute, we have an x squared. There's not a coefficient in front of it. Remember, coefficients are the numbers in front of variables. So when there's not a coefficient, it's always going to be treated like it has a coefficient of 1. Terms take the operation symbol directly to the left of the coefficient. So again, if you look down here at this example, we have 5x plus 20 plus 3x squared plus 2x minus x squared minus 9. When we're combining them in a minute, whatever it has in front of it is what you're going to do with it. So we have a minus x squared, so you would subtract x squared from the other x squareds. Or you have a plus 20, you would add that to the other numbers. And those other numbers are what we learned the other day are called constants. And constants are always like terms because you can always combine one number with another number. One key thing that you can use to help you learn how to do these and to keep track of what you're working with is to highlight the like terms the same color. So if you look at our example, again, we had 5x plus 20 plus 3x squared plus 2x minus x squared minus 9. You always want to start with the terms that have the variable raised to the highest power. In this case, that's going to be the second power. Then you want to move down to the next level, which would be 5x and plus 2x. Don't forget to grab the operation symbols because if you forget those, sometimes people get confused and always end up adding them instead of subtracting them if that's what you're supposed to do. So if you look, we can now look at this and see that we have 3 different terms in our final answer, and highlighting this helps you see that before you actually combine them together. So let's look at some examples where we actually have to combine our like terms. If you look at our first example, we have y plus y plus y plus y plus x. Well, if we highlight all of these y's together, we're going to leave it one color, and then we're going to highlight the x a completely different color. So nothing is raised to a higher power than the other. So we're just going to treat this like we would alphabetically. X comes before y, so I'm going to put x first, and then I want to have plus 4y. Because if you remember back to number 4 in our notes, it says if it doesn't have a coefficient, not number 4, but number 2, if it doesn't have a coefficient, treat it like it has a coefficient of 1. So that's 1y plus 1y plus 1y plus 1y, which is 1 plus 1 plus 1 plus 1, which is 4. Bring the variable with it. That's where the 4y comes from. Next, we have 3x plus 2y minus x plus 7y. Again, nothing has a higher power than anything else, so I'm going to work with the x's first. So I have a 3x minus an x, and then I have a 2y plus 7y. So when we're doing this, we want to have some trouble with the highlighter. So we have 3x minus x, which is going to give us 2x because 3 minus 1 is 2. And then we have a plus 2y plus 7y. So 2 plus 7 is 9, and that gives you 9y. So your answer for this one will be 2x plus 9y. The next one, however, we have the same variable throughout, but just like it did in our example for number 5, we have the same variable raised to different powers. So we have an 8x squared plus a 2x squared. Then we have a minus 3x, and we have just a positive 5 sitting out here by itself with no operation symbol. And we'll get to that in just a second. So when we start out, we have 8x squared plus 2x squared, and that's going to give you 10x squared. Then we have minus 3x, and then we have plus 5, because since that was a positive 5, you want to carry the plus symbol with that. Now, our last example, we have two different variables. We have a constant, so we're going to treat everything like we did before with it being alphabetical. So we have a minus 4x that we're going to worry about first. Then we have a 2z and a plus z. And then again, we just have a constant that's sitting out there by itself at the very end. So even though it's not normal to have a negative number as first number, that does happen from time to time. So with our first one, we're going to have minus 4x or negative 4x. And then 2z plus 1z is 3z. And then we have plus 9 out here at the end. So even though we do have a negative number first, that's okay. That will happen from time to time because sometimes you might have it where all of your terms are negative. Now, if you look on to the next page of your notes, there are 8 questions that are practice questions. Work on those. We will look at these and go over these to make sure you all are sure what you're doing. But that sums up our lesson for the day.